Welcome to the ultimate guide on recommendation systems. The engines powering Netflix, Amazon, Spotify, TikTok, and beyond. In this video, we'll walk through 200 carefully curated interview questions and answers, covering fundamentals, collaborative and content-based filtering, advanced algorithms, deep learning, applications, challenges, and the future of recommendations. Whether you're preparing for a data science interview or building real-world personalization systems, this is your one-stop masterclass on recommendation systems. What is a recommendation system? A recommendation system is an algorithmic approach that predicts user preferences and suggests items, such as movies, products, or music, that the user is likely to engage with. It's widely used by platforms like Netflix, Amazon, and Spotify to personalize experiences and boost user satisfaction and business outcomes. Why are recommendation systems important? They drive personalization and revenue growth. Businesses use them to increase engagement, retention, and sales by surfacing the right item at the right time. For example, Netflix saves billions annually by reducing churn through tailored recommendations. What are the main types of recommendation systems? The three main types are content-based filtering, uses item features to recommend similar items. Collaborative filtering leverages user-item interactions and similarity. Hybrid systems combine both to improve accuracy and overcome limitations. What is the cold start problem in recommendation systems? The cold start problem arises when there's not enough data about new users or new items. Without sufficient history, the system can't generate accurate recommendations. Hybrid methods, popularity-based ranking, or using side information like demographics help mitigate this. What is the difference between explicit and implicit feedback? Explicit feedback, direct signals like ratings or likes. Implicit feedback, indirect signals like clicks, purchases, or watch time. Most real-world systems rely on implicit feedback since it's abundant, though noisier. What are some common use cases of recommendation systems? Use cases include e-commerce, product recommendations, entertainment, movies, music, social media, friend or content suggestions, job portals, candidate matching, and healthcare, treatment personalization. Essentially, any domain needing personalization benefits from recommendations. What is the difference between content-based and collaborative filtering? Content-based methods use item features like movie genres to recommend similar items, while collaborative filtering uses user-item interaction patterns, like users who liked X also liked Y. Content-based works well for new users, while collaborative excels with rich interaction data. What is a hybrid recommendation system? A hybrid system combines content-based and collaborative filtering to balance their strengths. For example, Netflix blends collaborative filtering with content metadata. This improves accuracy, handles cold start better, and reduces bias from relying on a single method. What role does similarity play in recommendation systems? Similarity measures how closely items or users are related. For example, cosine similarity between movie vectors or Pearson correlation between user rating profiles. Higher similarity scores indicate stronger recommendation candidates. What are popularity-based recommendations? They suggest items that are trending or frequently consumed by the majority. While simple and effective for new users, they lack personalization and may reinforce popularity bias. Still, they're often used as baselines or fallback strategies. What are the key challenges in building recommendation systems? Challenges include cold start, scalability, data sparsity, bias, fairness, explainability, and privacy. Handling billions of users and items with real-time latency requirements makes engineering equally as important as algorithmic choice. What are user-based and item-based recommendations? User-based, find users similar to a target user and recommend items they liked. Item-based, find items similar to what the user consumed before. Item-based methods often scale better since item similarity is more stable than user similarity. What is matrix factorization in recommendation systems? Matrix factorization decomposes the user-item interaction matrix into latent factors representing users and items. By learning these embeddings, the system can predict missing interactions. Techniques like SVD and ALS are widely used in collaborative filtering. How do recommendation systems collect data? They collect data through explicit ratings, implicit behavior, clicks, purchases, demographic details, item metadata, and contextual signals like time and location. This data feeds into algorithms to learn user preferences. What is data sparsity in recommendation systems? In large systems, most users interact with only a few items, leaving the user item matrix sparse. This makes it hard to find patterns. Matrix factorization, embeddings, and hybrid systems help address sparsity. How do recommendation systems impact user experience? They enhance discovery, reduce choice overload, and create personalized journeys. For instance, Spotify curates personalized playlists that keep users engaged for hours. However, poor recommendations can frustrate users and harm trust. What is over-specialization in recommendation systems? Over-specialization happens when the system only suggests items very similar to a user's past preferences, reducing diversity and discovery. Hybrid approaches and diversity-promoting objectives help broaden recommendations. What ethical concerns exist in recommendation systems? Concerns include bias amplification, filter bubbles, lack of transparency, and misuse of personal data. For example, algorithms may unintentionally reinforce stereotypes or limit exposure to diverse viewpoints. Responsible AI practices are essential. How do recommendation systems handle scalability? They use distributed computing, approximate nearest neighbor (ANN) search, dimensionality reduction, and pre-computed similarity indexes. Platforms like YouTube and Amazon process billions of interactions daily using scalable architectures. What's the difference between offline and online evaluation in recommendation systems? Offline evaluation. Test algorithms on historical data using metrics like precision at K. Online evaluation. A/B testing on live users to measure real engagement, CTR, or revenue. Both are complementary, offline for speed, online for ground truth validation. What is content-based filtering in recommendation systems? Content-based filtering recommends items similar to those a user has liked in the past, based on item attributes. For example, if a user watches a sci-fi movie, the system suggests other movies with the sci-fi genre. It relies on item metadata like descriptions, tags, or embeddings. How does content-based filtering differ from collaborative filtering? Content-based filtering uses item features to recommend items regardless of other users' behavior, while collaborative filtering relies on user-item interaction patterns. Content-based methods avoid cold start for new users, but struggle when item features are limited. What types of item features are used in content-based filtering? Features can be structured, genre, price, category, brand. Unstructured, text descriptions, images, audio, or video embeddings. Advanced systems use NLP and deep learning to extract features automatically from raw data. How are similarity measures used in content-based filtering? Similarity measures like cosine similarity, Euclidean distance, or Pearson correlation compare item feature vectors. A higher similarity score means the items are more alike, guiding recommendations to match user interests. What is TF-IDF, and how is it applied in content-based filtering? TF-IDF, term frequency inverse document frequency, converts text into numerical features by emphasizing important words and downweighting common ones. For example, in movie descriptions, spaceship may weigh more than the. This helps recommend content based on meaningful textual features. What is cosine similarity and why is it popular? Cosine similarity measures the cosine of the angle between two vectors. It's scale independent, focusing on orientation rather than magnitude. That makes it ideal for comparing TF-IDF or embedding vectors in recommendation systems. How do word embeddings improve content-based recommendations? Embeddings like word2vec, GLOVE, or BERT represent words in dense vectors that capture semantic meaning. They allow the system to recognize that sci-fi and space adventure are related, improving recommendations beyond keyword matching. How is dimensionality reduction used in content-based filtering? Techniques like PCA, SVD, or autoencoders reduce high-dimensional feature vectors into compact representations. This improves efficiency and removes noise, making similarity comparisons faster and more meaningful. How do you build a user profile in content-based filtering? A user profile aggregates features from items the user has interacted with. For example, if they watch mostly action and thriller, their profile emphasizes those genres. Future recommendations are matched against this profile. What are the strengths of content-based filtering? Advantages include works well for new users, no need for data from other users, provides explainable recommendations. We recommended this because you liked X. It's ideal for domains where item features are rich and informative. What are the weaknesses of content-based filtering? Limitations include struggles with new items if features are sparse, over-specialization, limited diversity, requires high-quality metadata. It often lacks novelty compared to collaborative filtering. How does over-specialization affect content-based systems? The system may repeatedly recommend items similar to past preferences, narrowing user exposure. For example, if a user likes one jazz song, they may only see jazz and miss pop or rock. Adding diversity objectives or hybridizing helps mitigate this. What role does feature engineering play in content-based filtering? Feature engineering defines how items are represented. Well-designed features capture what makes items relevant, such as extracting genres from movies or embeddings from images. Poor feature engineering reduces recommendation quality, even with good algorithms. How can deep learning improve feature extraction for content-based filtering? Deep learning models automatically learn item features from raw data, CNNs for images like product pictures, RNNs or transformers for text like descriptions, reviews. This enables more accurate similarity matching and richer recommendations. How do you handle unstructured data in content-based filtering? Unstructured data like text, images, or audio is converted into feature vectors using NLP, CNNs, or embeddings. These features are then used for similarity calculations, enabling recommendations beyond structured metadata. What is a content similarity matrix? It's a pre-computed matrix where each entry represents similarity between two items based on their features. This allows fast retrieval of top-end similar items during recommendation without recalculating similarity each time. How do you combine multiple feature types in content-based filtering? You can concatenate vectors from text, image, and metadata features, or use weighted combinations depending on importance. Advanced models like multimodal embeddings unify diverse feature types into a single representation. How can feedback loops affect content-based filtering? If recommendations are based only on past behavior, they may reinforce existing patterns. For example, a user who reads one tech article may only see tech content, never discovering other interests. Regular diversification helps avoid this bias. How do you evaluate content-based filtering models? Evaluation uses offline metrics like precision at K, recall at K, and NDCG on held-out data. Online A/B testing measures real engagement, CTR, or dwell time. Explainability and diversity are also important evaluation aspects. What are real-world examples of content-based filtering? Spotify recommends songs based on acoustic features and lyrics. Amazon suggests products with similar descriptions or attributes. LinkedIn recommends jobs based on skills and experience listed in user profiles. What is collaborative filtering in recommendation systems? Collaborative filtering CF recommends items based on the behavior of similar users. Instead of item features, it relies on the user-item interaction matrix. If user A and user B have similar preferences, items liked by A can be recommended to B. What are the two main types of collaborative filtering? User-based CF finds users similar to the target user and recommends items they liked. Item-based CF finds items similar to what the user has already interacted with. Item-based CF generally scales better for large systems. How does user-based collaborative filtering work? It calculates similarity between users. Example is cosine similarity of rating vectors. Recommendations are generated by looking at items consumed by similar users. For example, If similar users watched a certain movie, it's suggested to the target user. How does item-based collaborative filtering work? It computes similarity between items based on user interaction patterns. If many users who watch movie A also watch movie B, then B is recommended when a user watches A. It's more stable since item relationships change less frequently than user relationships. What is the user-item interaction matrix? It's a matrix where rows represent users, columns represent items, and values are interactions, like ratings, clicks, purchases. Most entries are missing, leading to sparse matrices. Collaborative filtering algorithms learn from these sparse patterns. What is the cold start problem in collaborative filtering? Cold start happens with new users, no history, or new items, no interactions. CF can't recommend effectively without past data. Solutions include hybrid systems, popularity-based fallback, or using content-based features. What is data sparsity, and why is it a challenge in CF? In real-world systems, most users interact with very few items, leaving most of the user item matrix empty. This makes similarity computations noisy and reduces recommendation quality. Techniques like matrix factorization reduce sparsity impact. How is similarity computed in collaborative filtering? Common similarity measures include cosine similarity, Pearson correlation, and Jacquard index. These are applied to user rating vectors, user-based CF, or item rating vectors, item-based CF. The choice depends on the data and interaction type. What is matrix factorization in collaborative filtering? Matrix factorization decomposes the user item matrix into two lower dimensional matrices, user factors and item factors. Multiplying them reconstructs missing interactions. This approach captures latent features such as action movie fan or budget shopper. What is singular value decomposition, SVD, in CF? SVD is a matrix factorization technique that breaks the user item matrix into latent components. It reduces dimensionality and reveals hidden patterns. In CF, truncated SVD predicts missing ratings by reconstructing approximations of the sparse matrix. How does alternating least squares, ALS, work in CF? ALS optimizes user and item factor matrices by alternating updates. Fix one and solve for the other iteratively. It's efficient for large datasets and popular in distributed systems like Spark ML-LIB for recommender systems. What is implicit feedback in CF and how is it handled? Implicit feedback includes clicks, purchases, or views instead of explicit ratings. It's abundant but noisy. Algorithms like implicit matrix factorization weigh positive interactions more while treating missing data as weak negatives. How do neighborhood models differ from latent factor models? Neighborhood models rely on direct similarities between users or items, while latent factor models like SWFD capture hidden dimensions. Neighborhoods are easier to explain, but latent factor models scale better and capture deeper patterns. What is the Netflix prize and why was it important? The Netflix prize, 2006 to 2009, challenged researchers to improve its recommendation system. Matrix factorization methods, especially SVD variants, dominated the competition, sparking widespread adoption of CF and advancing research in recommender systems. What are advantages of user-based CF? Easy to implement. Provides interpretable recommendations. Similar users liked X. Works well in small data sets, but it doesn't scale as well in massive systems with millions of users. What are advantages of item-based CF? More stable, since item similarity doesn't change as quickly as user similarity. Scales better in large data sets. Works well for sparse matrices. This is why Amazon heavily uses item-based CF for product recommendations. What are limitations of collaborative filtering? CF struggles with cold start, sparsity, and scalability. It also suffers from popularity bias, where niche items rarely get recommended. Additionally, pure CF lacks explainability compared to content-based systems. How do hybrid models improve collaborative filtering? Hybrid systems combine CF with content-based filtering or contextual features. For example, when CF struggles with cold start, content-based methods fill the gap. Hybrids generally provide more accurate, diverse, and robust recommendations. How do you evaluate collaborative filtering models? Offline. precision at K, recall at K, MAP, NDCG on historical datasets. Online, A/B testing with CTR, conversions or engagement. Evaluation must balance accuracy, diversity, novelty, and fairness. What are some scalability strategies for CF? Strategies include using dimensionality reduction, like SVD, PCA, approximate nearest neighbor search, like FAISS, ANNOY, distributed computing, like Spark, pre-computing similarity matrices for frequent queries. What is the role of regularization in matrix factorization? Regularization prevents overfitting by penalizing large latent factor weights. Without it, the model may memorize noise in sparse datasets. Techniques like L2 regularization are common in SVD and ALS implementations. How does probabilistic matrix factorization work? It treats observed ratings as probabilistic outcomes with Gaussian noise. User and item latent factors are learned by maximizing likelihood. This Bayesian approach provides uncertainty estimates alongside predictions. What is non-negative matrix factorization, NMF? NMF decomposes the matrix into non-negative factors, ensuring interpretability. Latent factors represent additive user preferences, making results easier to explain. For example, user preference for action plus comedy is more intuitive than abstract latent features. How does collaborative filtering handle dynamic user preferences? Standard CF assumes static preferences, but users evolve. Solutions include time-aware CF, weighting recent interactions more, or sequence models that account for order of interactions, bridging toward session-based recommendations. What is biased matrix factorization? It extends MF by adding global, user, and item bias terms. For example, some users tend to rate higher, and some items are generally more popular. Adding bias terms improves accuracy, as seen in Netflix prize-winning models. How does K-nearest neighbors, KNN, apply to CF? In user-based CF, KNN finds the top K similar users to a target user. In item-based CF, it finds top K similar items to one the user liked. Though simple, it's effective in small to medium-scale systems. What is the role of confidence weights in implicit CF? Since implicit data is noisy, confidence weights distinguish strong signals, purchases, long watch times, from weak ones, clicks, skips. Weighted MF, Hukaran-Valinsky model, uses these confidence scores to improve predictions. How can deep learning enhance collaborative filtering? Neural collaborative filtering replaces dot products in MF with neural networks, learning nonlinear interactions between users and items. This captures complex relationships and generalizes better across diverse datasets. What are real-world applications of collaborative filtering? Amazon, product-based recommendations. YouTube, video recommendations based on watch histories. Goodreads, book recommendations via similar readers. CF powers most large-scale consumer recommendation platforms. When should collaborative filtering not be used? CF is less effective when new users or items dominate, like cold start. Interaction data is extremely sparse. Interpretability is critical. In these cases, content-based or hybrid methods are better suited. What are latent factor models in recommendation systems? Latent factor models represent users and items in a shared low-dimensional space. Each user and item is mapped into vectors, and their dot product predicts interaction strength. These models uncover hidden traits, like a user's affinity for genres or an item's style, without explicit feature engineering. How do latent factor models improve over neighborhood methods? Neighborhood methods rely on observed similarities, which fail with sparse data. Latent factor models infer hidden dimensions, allowing predictions even for users or items with limited overlap. This makes them more scalable and accurate for large, sparse datasets. What is probabilistic matrix factorization, PMF? PMF models user-item interactions probabilistically, assuming Gaussian noise around latent factor predictions. It provides uncertainty estimates, which are useful in domains like finance or healthcare, where knowing prediction confidence is as important as accuracy. How does Bayesian personalized ranking, BPR, work? BPR is designed for implicit feedback. Instead of predicting ratings, it optimizes pairwise ranking. Given that a user preferred item A over B, the model learns latent factors to rank A above B. This is effective for recommendation ranking tasks. What are factorization machines, FM? Factorization machines generalize matrix factorization by modeling interactions between all features, user ID, context variables. They work well with sparse data and are widely used in ad recommendation systems like CTR prediction. How do field-aware factorization machines FFMS differ from FMS? FFMS extend FMS by learning different embeddings depending on the field of the feature. For example, user age interacts differently with item category versus item brand. This increases modeling flexibility but adds computational cost. What is the role of deep factorization machines? DeepFM combines factorization machines with deep neural networks. The FM part captures low-order feature interactions, while the deep network captures high-order, nonlinear interactions. This hybrid is effective for CTR prediction and ranking tasks at scale. How do autoencoders apply to recommendation systems? Autoencoders compress user item interactions into latent codes and reconstruct missing values. Variational autoencoders, VAES, extend this by modeling distributions. They're effective for implicit feedback and can outperform classical MF in certain scenarios. What is the role of restricted Boltzmann machines RBMS in Recsys? RBMS are generative models that learn user item interaction patterns. Netflix famously used RBMS during the Netflix Prize. While less common today, RBMS inspired many deep learning approaches in recommender systems. How do graph-based methods enhance recommendations? Users and items can be modeled as nodes in a bipartite graph, with interactions as edges. Graph algorithms, like random walks or graph neural networks, capture higher-order connectivity, enabling recommendations based on multi-hop relationships. What is graph collaborative filtering? GraphCF? GraphCF integrates collaborative filtering with graph embeddings. By propagating user and item interactions over a graph, it captures complex connectivity patterns. GCN-based recommender models are state-of-the-art in many domains like social networks. What is light GCN in recommendation systems? Light GCN is a simplified graph convolutional network for CF. It removes nonlinearities and feature transformations, focusing only on neighborhood aggregation. This simplification improves scalability and efficiency while maintaining strong accuracy. How do reinforcement learning methods apply to Recsys? RL treats recommendation as a sequential decision process, where the system learns to maximize long-term user engagement. Instead of static ranking, it adapts recommendations based on feedback, balancing exploration novel items and exploitation familiar favorites. What is session-based recommendation? Session-based Recsys focuses on predicting user actions within a single session, often without long-term history. RNNs, or transformers, track the sequence of interactions. This is common in e-commerce and news sites where user IDs may not be persistent. How does sequential recommendation differ from session-based recommendation? Sequential recommendation considers long-term sequences of user actions across sessions, not just one. It models evolving preferences over time. Techniques include Markov models, RNNs, or transformers for time-aware personalization. What is knowledge graph-based recommendation? Knowledge graphs link users, items, and attributes in a structured graph. Recommenders use paths through the graph, like user to liked movie to actor to other movies, to generate explainable recommendations. They improve diversity and explainability. How do hybrid latent factor and content-based models work? These models enrich latent factors with item or user-side features. For example, movie embeddings can combine collaborative signals with genre metadata. This reduces cold start and improves interpretability. What is neural collaborative filtering, NCF? NCF replaces the dot product in MF with neural networks, learning nonlinear interactions between user and item embeddings. It generalizes matrix factorization and performs well on complex datasets with implicit feedback. How do attention mechanisms improve recommendation systems? Attention highlights the most relevant past interactions for a recommendation. For example, instead of treating all user clicks equally, it weights recent or contextually important ones higher. Attention-based models power session-based and sequential Recsys. What are some real-world applications of latent factor models? Netflix. Personalized movie recommendations using MF. Spotify. Playlist continuation with embeddings. E-commerce. Product ranking with FMs in DeepFM. Latent factor models are the backbone of large-scale recommendation engines. How is deep learning used in recommendation systems? Deep learning enhances Recsys by automatically learning complex, nonlinear relationships between users and items. Instead of handcrafted similarity, it uses embeddings, neural networks, and sequence models to capture deeper patterns in user behavior, item content, and context. What are embeddings in recommendation systems? Embeddings map users and items into dense, low-dimensional vectors. These capture latent preferences and similarities that are not obvious in raw data. For example, two songs with different genres but similar mood can be placed close in embedding space. How do neural networks improve collaborative filtering? Neural collaborative filtering, NCF, replaces the dot product in matrix factorization with a neural network that learns nonlinear interactions between user and item embeddings. This captures richer relationships and boosts accuracy on implicit datasets. What role do autoencoders play in Recsys? Autoencoders compress user-item interactions into latent representations and reconstruct missing values. Variational autoencoders, VAES, extend this by modeling uncertainty. They're effective for implicit feedback and outperform classical MF in certain scenarios. How are convolutional neural networks, CNNs, used in recommendation systems? CNNs extract features from unstructured content like images, audio, or video. For example, e-commerce sites use CNNs to model product images, improving visual recommendations, while music platforms use CNNs for spectrogram-based audio similarity. How are recurrent neural networks, RNNs, applied to recommendation systems? RNNs model sequential user behavior, such as click or watch histories. They capture order and temporal dependencies, making them ideal for session-based and sequential recommendations in domains like news, e-commerce, and streaming services. What are the drawbacks of RNN-based recommendation models? RNNs struggle with long sequences due to vanishing gradients and are hard to parallelize. Training can be slow for large-scale systems. This led to the adoption of attention-based and transformer models that handle long-term dependencies more efficiently. How do attention mechanisms improve recommendations? Attention weights recent or relevant interactions more heavily, letting the model focus on what matters. For example, if a user clicked many products, attention highlights the last few clicks when predicting the next one. It enhances interpretability and accuracy. What is the role of transformers in recommendation systems? Transformers use self-attention to model long-range dependencies in user interactions. They handle sequential recommendations at scale, making them popular in session-based e-commerce, video recommendations, and personalized news feeds. What is BERT4-Rec? BERT4-Rec adapts BERT's mask language modeling approach to recommendation. It masks some user-item interactions and predicts them, capturing bidirectional context. This improves sequential recommendation accuracy compared to unidirectional RNNs. How do generative adversarial networks, GANs, apply to recommendation systems? GANs can generate synthetic user-item interactions to overcome data sparsity. The generator proposes candidate items, and the discriminator evaluates them. This adversarial setup helps improve robustness and ranking in sparse datasets. How are graph neural networks, GNNs, used in recommendation systems? GNNs operate on user-item interaction graphs, propagating embeddings through neighbors. They capture higher-order connectivity, like friends of friends, and improve recommendations in social networks, knowledge graphs, and e-commerce platforms. What is PinSage? PinSage is a scalable GNN-based recommendation system developed by Pinterest. It combines graph convolutions with random walks to capture both local and global item relationships, enabling high-quality recommendations on billion-scale graphs. What is the temporal fusion transformer, TFT, in Recsys? TFT, though originally built for forecasting, can be adapted for Recsys by handling sequential context, static features, and dynamic covariates. Its attention layers highlight the most relevant factors driving recommendations at each step. How does reinforcement learning combine with deep learning in Recsys? Deep reinforcement learning treats recommendations as sequential decisions. For example, recommending a series of videos to maximize long-term watch time. DRL balances exploration, diverse items, and exploitation, popular items for long-term engagement. How does knowledge distillation help in deep learning Recsys? Knowledge distillation compresses large models into smaller ones while retaining performance. For example, a large transformer trained offline can transfer knowledge to a lightweight model deployed in real-time systems. This reduces latency without major accuracy loss. What is a multimodal recommendation system? Multimodal Recsys combine features from multiple data types: text, descriptions, images, product photos, audio, music, and structured metadata. Deep models like GNNs and transformers merge these signals into unified embeddings for richer personalization. How does deep reinforcement learning DRL improve recommendations? DRL optimizes recommendations for long-term rewards rather than immediate clicks. For example, instead of maximizing CTR, it learns policies that improve retention or lifetime value, making recommendations more strategic. What is YouTube's deep learning recommendation architecture? YouTube uses a two-stage model: candidate generation with deep embeddings, ranking model with deep neural networks that optimize for engagement signals like watch time. This architecture balances scalability and personalization on billions of users and videos. What is wide and deep learning in recommendation systems? Wide and deep combines linear models, memorization of co-occurrence patterns, with deep networks, generalization to unseen features. Used by Google Play, it ensures both memorized and novel recommendations are effective. How do sequence-to-sequence models apply to recommendation? Sequence-to-sequence models treat user interaction history as an input sequence and predict future interactions as an output sequence. This is effective for predicting next clicks or multi-step purchases in e-commerce and content consumption. What is SAS-REC? SAS-REC is a self-attention-based sequential recommender. It models dependencies between user interactions using unidirectional self-attention, enabling it to outperform RNN-based models in session-based recommendation tasks. How do context-aware deep models work in Recsys? These models incorporate contextual signals like time, location, or device type alongside user item interactions. For instance, a restaurant app may recommend different cuisines at lunchtime versus dinner. Deep models learn context-conditioned embeddings. What is deep crossing in recommendation systems? Deep crossing, developed by Microsoft, is a deep neural network that learns feature interactions end-to-end without manual feature engineering. It handles sparse categorical data, common in Recsys tasks like CTR prediction. How does the DIN Deep Interest Network work? DIN uses attention to model user interest dynamically. It assigns higher weights to past interactions most relevant to the target item. For example, in e-commerce, it highlights the user's clothing purchases when recommending another fashion item. What is the DIEN, Deep Interest Evolution Network? DIN extends DIN by modeling how user interests evolve over time using GRUS and attention. It captures both long-term preferences. What are multitask learning models in Recsys? Multitask models jointly optimize multiple objectives like CTR, conversions, and dwell time. Sharing representations improves generalization and balances trade-offs. For example, TikTok optimizes for both engagement and diversity. How does deep learning address the cold start problem? By leveraging side information like images, text, or user demographics, deep models can generate embeddings for new items or users. For example, a CNN on product images allows recommendations even before purchase history exists. What is meta-learning in recommendation systems? Meta-learning enables models to adapt quickly to new users or items with minimal data. Few-shot recommendation techniques apply meta-learning to personalize faster, especially in cold start or dynamic environments. What is the role of large language models LLMs in recommendation systems? LLMs can interpret unstructured feedback, generate embeddings, and even act as reasoning engines to explain or justify recommendations. They're increasingly integrated into hybrid Recsys pipelines to improve personalization and interpretability. What are context-aware recommendation systems? Context-aware systems incorporate additional information like time, location, device type, or mood when generating recommendations. For example, a food delivery app may suggest coffee in the morning, but dinner meals at night, improving personalization beyond static preferences. How do contextual features improve recommendations? They help capture the when, where, and how of user interactions. For example, the same user might watch comedies at night but news in the morning. By modeling context, the system tailors recommendations to dynamic preferences. What are examples of contextual signals used in Recsys? Common signals include time of day, location, device, season, weather, user activity, and social context. Spotify uses time and device to suggest playlists, while Uber Eats uses location and time for food recommendations. How is time used as context in recommendation systems? Time can indicate patterns such as weekends versus weekdays, morning versus evening, or holidays. For example, retail apps recommend holiday-related products in December, while Netflix promotes family movies on weekends. What is location-aware recommendation? Location-aware systems use GPS or IP data to suggest items relevant to the user's surroundings. For example, Google Maps recommends nearby restaurants, while ride-sharing apps suggest rides from the user's exact location. What is a session-based recommendation system? Session-based Recsys predict the next item based on a single browsing session without long-term user history. This is common in anonymous e-commerce visitors or news apps where quick, short-term intent matters more than past preferences. How do sequential models differ from session-based models? Sequential models look at long-term user behavior across sessions, while session-based models focus on short-term context. For example, a fashion site may use sequential models for overall style preferences, but session models for immediate intent. What is a personalized ranking model? Personalized ranking models optimize recommendation order for each user instead of providing the same global ranking. For instance, Amazon sorts search results differently for each customer based on past purchases and browsing history. How do contextual bandits work in recommendation systems? Contextual bandits extend multi-armed bandits by incorporating context like time, device, or user demographics. The system balances exploration, trying new items, and exploitation, showing known favorites, to maximize rewards such as CTR. How does reinforcement learning extend beyond contextual bandits in Recsys? While contextual bandits optimize single-step decisions, RL optimizes long-term engagement. For example, instead of maximizing a single click, RL recommends a sequence of videos that maximize total watch time. What are multi-objective recommendation systems? These systems balance multiple goals such as accuracy, diversity, serendipity, and fairness. For example, TikTok optimizes for engagement, but also ensures content variety and safety. Multitask learning and weighted loss functions are common approaches. How does personalization differ from general recommendations? General recommendations suggest popular or trending items, while personalized recommendations adapt to individual preferences. Personalization improves relevance and user satisfaction, but requires more data and computation. How do demographic-based recommendations work? They use user demographics like age, gender, or location to cluster users and provide group-level recommendations. While simple, this method risks stereotyping and lacks personalization compared to behavior-based methods. How do context-aware embeddings improve Recsys? Instead of static embeddings, context-aware embeddings adapt user and item representations based on external signals. For example, a user's movie preferences may shift between weekdays and weekends, requiring dynamic embeddings. What is serendipity in recommendations? Serendipity refers to pleasantly surprising users with relevant but unexpected items. For example, recommending a new indie band to a rock music fan. Serendipity prevents overspecialization and keeps recommendations fresh. What is novelty in recommendation systems? Novelty measures how new or unknown an item is to a user. Unlike serendipity, which balances relevance and surprise, novelty emphasizes exposing users to items they haven't interacted with before. How do you balance accuracy and diversity in recommendations? This involves trade-offs. Too much accuracy can lead to redundancy, while too much diversity can reduce relevance. Techniques like re-ranking, diversification algorithms, or multi-objective optimization balance the two. What role does explainability play in context-aware Recsys? Explainability builds trust by showing why an item was recommended, such as because you watched X last night, or popular in your area. This transparency increases user acceptance and satisfaction. What are cross-domain recommendations? Cross-domain Recsys transfer knowledge from one domain to another. For example, using a user's movie preferences to recommend books or games. This expands personalization and helps solve sparsity in one domain. What are examples of real-world context-aware recommendation systems? Netflix, time of day personalized content. Spotify, context playlists like morning commute. Amazon, location and seasonal-based product suggestions. Uber Eats, meal recommendations based on time and location. Why is evaluation important in recommendation systems? Evaluation ensures the system provides relevant, diverse, and useful suggestions. It helps measure performance, identify weaknesses, and balance trade-offs like accuracy versus diversity. Without rigorous evaluation, even accurate models may harm user satisfaction or business goals. What is offline evaluation in recommendation systems? Offline evaluation tests models on historical data using metrics like precision at K or R, MSE. It's fast and cheap, but doesn't always reflect real-world behavior, since users may act differently in live environments. What is online evaluation in recommendation systems? Online evaluation measures performance with live users, typically via A/B testing. For example, two models are deployed, and engagement, CTR, or retention are compared. While costly, it provides the most reliable ground truth. What is precision at K in Recsys evaluation? Precision at K measures the fraction of recommended items in the top K list that are relevant. For example, if 5 out of 10 recommended movies are relevant, precision at 10 equals 0.5. It reflects short-term accuracy. What is recall at K, and why is it important? Recall at K measures how many of the user's relevant items are captured in the top K recommendations. High recall ensures coverage of user interests, but it may sacrifice precision if many irrelevant items are included. What is mean average precision, MAP? MAP averages precision across multiple cutoffs and users. It rewards algorithms that place relevant items higher in the ranking. MAP is especially useful when ranking order strongly influences engagement. What is normalized discounted cumulative gain, NDCG? NDCG evaluates ranking quality by giving higher weight to relevant items placed at the top. For example, recommending a relevant movie in the top 3 is better than at rank 10. It reflects real-world user browsing behavior. What is AUC area under curve in recommendation systems? A UC measures the probability that a randomly chosen relevant item is ranked higher than a non-relevant one. It's widely used for binary implicit feedback tasks like click prediction, as it handles imbalanced datasets well. What is RMSE in recommendation systems? Root mean squared error measures the difference between predicted ratings and actual ratings. While common in early Recsys research, RMSE doesn't always align with ranking quality or business outcomes in modern implicit feedback systems. What are coverage metrics in recommendation systems? Coverage measures how much of the catalog gets recommended across users. High coverage ensures users discover niche items, while low coverage means the system only pushes popular items, reducing diversity. What is diversity in recommendation evaluation? Diversity measures how varied the recommended items are. For example, instead of only suggesting action movies, the system also includes drama or comedy. Diversity prevents over-specialization and increases user satisfaction. What is novelty in recommendation evaluation? Novelty evaluates how new or unfamiliar recommended items are to the user. High novelty exposes users to fresh content, but excessive novelty can reduce relevance if items feel random. What is serendipity in recommendation systems? Serendipity measures the extent to which recommendations are both relevant and pleasantly surprising. For example, suggesting a new indie artist that aligns with a user's taste but wasn't expected. It balances relevance with discovery. What is personalization in evaluation metrics? Personalization measures how unique recommendations are for each user. A high personalization score means users receive distinct lists, while low personalization indicates most users see the same popular items. What are fairness metrics in recommendation systems? Fairness ensures recommendations don't disproportionately disadvantage groups or items. For example, giving equal exposure to small vendors alongside large brands. Metrics may assess demographic parity, is exposure fairness, or bias amplification. What are calibration metrics in recommendation evaluation? Calibration checks whether the distribution of recommended items matches the user's historical preferences. For example, if a user watches 70% comedies and 30% dramas, the recommendation list should roughly reflect that ratio. What are business-oriented metrics in Recsys evaluation? These include click-through rate, CTR, conversion rate, revenue lift, churn reduction, or watch time. They directly measure whether recommendations meet organizational goals beyond technical accuracy. What is backtesting in recommendation evaluation? Backtesting simulates recommendations on historical interaction logs to see how users would have responded. It's useful for validating models before deployment, but limited by the assumption that past behavior predicts future behavior. What is multi-metric evaluation in recommendation systems? Multi-metric evaluation uses a combination of metrics. Examples are precision, NDCG, diversity, and CTR, instead of relying on one. This balances trade-offs and avoids over-optimizing for a single objective that may harm user experience. How do you choose the right evaluation metrics for a recommendation system? It depends on the application. E-commerce, precision, revenue, conversions, streaming, recall, watch time, diversity, social media, engagement, novelty, fairness. The right metrics align with both user satisfaction and business goals. How are recommendation systems used in e-commerce? In e-commerce, Recsys drive product discovery by suggesting items based on browsing history, purchase behavior, or similar users. Amazon attributes a significant portion of its revenue to recommendations like frequently bought together and customers who bought this also bought. How does Netflix use recommendation systems? Netflix personalizes movie and TV suggestions using collaborative filtering, content-based metadata, and deep learning. Around 80% of viewing activity comes from recommendations, reducing churn and increasing engagement significantly. How does YouTube apply recommendation systems? YouTube uses a two-stage system, candidate generation with deep embeddings and ranking based on engagement signals like watch time. Its Recsys drives billions of daily views, shaping what users watch globally. How does Spotify personalize recommendations? Spotify combines collaborative filtering, audio embeddings, and NLP on lyrics to generate playlists like Discover Weekly. It also uses contextual signals like time of day and device type for personalized playlist suggestions. How do social media platforms use recommendation systems? Platforms like Facebook, Instagram, and TikTok use Recsys to recommend posts, reels, or friends. These systems leverage user interactions, content embeddings, and engagement optimization to maximize retention and ad revenue. How are recommendation systems applied in retail? Retailers use Recsys for personalized promotions, product bundles, and cross-selling. For example, Walmart applies AI-powered recommendations in both online and physical stores to increase basket size and optimize product placement. How does LinkedIn use recommendation systems? LinkedIn employs Recsys for job recommendations, people you may know, and learning content. It leverages graph-based models, embeddings, and personalization to connect professionals and enhance platform engagement. How are recommendation systems applied in finance? In finance, Recsys suggest personalized investment products, credit card offers, or financial advice. Robo-advisors use them to tailor portfolios, while banks apply them to cross-sell loans or savings products. How do healthcare systems use recommendation systems? Healthcare Recsys recommend treatments, clinical guidelines, or wellness programs. For example, wearable devices suggest lifestyle changes based on sensor data, while hospitals use Recsys for personalized care pathways. How are recommendation systems applied in online advertising? Ad recommendation systems predict the best ads to display for each user, optimizing for CTR or conversions. Platforms like Google Ads and Facebook Ads rely heavily on collaborative filtering, FMs, and deep learning to maximize ad relevance and revenue. What role do recommendation systems play in news platforms? News apps like Google News or Flipboard use Recsys to suggest personalized articles. They combine content-based filtering with contextual factors like recency, ensuring users see relevant and timely stories. How does TikTok use recommendation systems? TikTok's For You page is powered by deep reinforcement learning and transformers. It optimizes for engagement, novelty, and diversity, adapting rapidly to micro-patterns in user behavior, like replays or watch duration. How are recommendation systems used in education platforms? Platforms like Coursera or Duolingo recommend personalized learning paths, exercises, or courses. These systems adapt to the learner's progress, balancing difficulty, mastery, and engagement. How do travel platforms use recommendation systems? Travel apps like Airbnb and Expedia recommend destinations, hotels, and experiences based on user history, seasonality, and peer reviews. Context-aware Recsys also consider time and location to suggest relevant options. How are recommendation systems applied in gaming? Gaming platforms use Recsys to recommend in-game items, downloadable content, DLCS, or similar titles. Steam, for example, uses collaborative filtering and embeddings to suggest games aligned with player preferences. How do recommendation systems help in B2B platforms? In B2B marketplaces, Recsys suggest suppliers, business tools, or partners. For example, Alibaba recommends vendors to buyers based on transaction history, ratings, and geographic preferences. How do hybrid recommendation systems improve e-commerce personalization? Hybrid systems combine content metadata, collaborative filtering, and deep learning to cover multiple angles. For instance, Amazon integrates product features with purchase behavior, ensuring recommendations are accurate, diverse, and cold start resistant. What are examples of graph-based recommendation systems in real-world platforms? Pinterest Pin Sage for item discovery. LinkedIn, people you may know using graph embeddings. Twitter follow recommendations leveraging social network graphs. These highlight the importance of connectivity and personalization. How do recommendation systems handle real-time personalization? They use streaming data pipelines and approximate nearest neighbor search for rapid updates. For example, YouTube and TikTok update recommendations within seconds based on immediate actions, like likes, skips, or replays. What are some failures of real-world recommendation systems? Failures include reinforcing biases, creating filter bubbles, or surfacing harmful content. For example, YouTube has been criticized for pushing extreme content due to engagement-driven objectives. These failures highlight the importance of fairness and responsible design. What are the main challenges in recommendation systems? Key challenges include cold start, data sparsity, scalability, bias, fairness, privacy, and explainability. Modern systems must also handle real-time personalization and balance accuracy with diversity, novelty, and long-term engagement. What is the cold start problem in recommendation systems? The cold start problem occurs when recommending for new users or new items with little or no interaction data. Without history, collaborative filtering fails. Solutions include hybrid models, demographic-based features, and leveraging content embeddings. How does data sparsity affect recommendation quality? In large systems, most users interact with very few items, leaving the user item matrix extremely sparse. This reduces overlap for similarity-based methods. Approaches like matrix factorization, embeddings, and cross-domain transfer help mitigate sparsity. What is popularity bias in recommendation systems? Popularity bias favors well-known or trending items, making niche items less likely to be recommended. While it boosts short-term engagement, it hurts diversity and long-tail discovery. Algorithms must rebalance exposure across items. What is the filter bubble problem? Filter bubbles occur when recommendations repeatedly expose users to the same types of content, narrowing perspectives. For example, a news Recsys may only show one political viewpoint. This limits serendipity and may reinforce polarization. How do recommendation systems address fairness issues? Fairness ensures equal exposure for users and items. For example, giving fair visibility to small sellers on e-commerce platforms. Solutions include fairness-aware ranking, reweighting algorithms, and fairness metrics in evaluation. Why is explainability important in recommendation systems? Explainability builds user trust and compliance with regulations. For example, showing, "We recommended this job because it matches your skills," helps users understand and accept suggestions. Techniques include attention visualization, rule-based explanations, or knowledge graphs. How do scalability challenges affect large-scale recommendation systems? Systems like Amazon or YouTube must handle billions of interactions daily. Scalability challenges include storage, computation, and real-time updates. Solutions involve distributed training, approximate nearest neighbor search, and streaming architectures. How do privacy concerns impact recommendation systems? Recsys rely on sensitive personal data, raising privacy concerns. Regulations like GDPR require data minimization, user consent, and explainability. Techniques like federated learning and differential privacy protect users while enabling personalization. How do recommendation systems deal with dynamic user preferences? User tastes evolve over time. Static models risk recommending outdated items. Dynamic approaches include time-aware embeddings, sequential models, RNNs, transformers, and reinforcement learning that adapts to changing behaviors in real time. What are the major trends shaping the future of recommendation systems? The future will be driven by deep learning, graph neural networks, reinforcement learning, multimodal data integration, and large language models (LLMs). Systems will focus more on explainability, fairness, privacy, and long-term user engagement over short-term clicks. How will graph neural networks (GNNs) shape future recommendation systems? GNNs capture complex multi-hop relationships in user item graphs, enabling better personalization and explainability. As platforms scale, graph-based Recsys will become central, powering use cases like social recommendations, fraud detection, and multimodal discovery. What role will multimodal recommendation systems play? Future systems will combine text, audio, video, and images to create holistic personalization. For example, e-commerce may blend product descriptions, images, and reviews, while music platforms mix audio features with lyrics and context. How will reinforcement learning influence recommendation systems? RL will enable long-term optimization by focusing on retention, satisfaction, and lifetime value rather than single clicks. It will make Recsys more adaptive, balancing exploration and exploitation in real time. What role will large language models (LLMs) play in recommendation systems? LLMs can reason about user intent, summarize feedback, generate explanations, and create embeddings from unstructured data. They'll be key in conversational recommenders, where users interact in natural language to refine preferences dynamically. How will conversational recommendation systems evolve? They'll shift from static lists to interactive dialogue-driven systems where users refine preferences in real time. Powered by LLMs and RL, these systems will make personalization more natural, transparent, and engaging. How will federated learning impact recommendation systems? Federated learning allows training across user devices without centralizing data, preserving privacy. For example, Google's Gboard personalizes next word predictions locally. Future Recsys will increasingly rely on federated and privacy-preserving methods. How will explainability evolve in future recommendation systems? Explainability will move beyond simple tags to rich, human-like narratives. For instance, "We recommended this course because you've been learning data science, and others like you found it helpful. This will enhance transparency and compliance. What are the biggest open challenges for recommendation research? Open challenges include addressing bias and fairness, handling multi-objective optimization, ensuring robustness to adversarial attacks, integrating domain knowledge, and building scalable systems that adapt to rapidly shifting user preferences. What is the ultimate vision for recommendation systems in the future? The ultimate vision is agentic AI recommenders that act as personalized assistants. Instead of passively suggesting, they proactively curate content, explain trade-offs, adapt to real-time signals, and align with user values. Bridging personalization with responsible AI. Thanks for watching. You've just completed 200 expert-level interview questions and answers on recommendation systems. From the basics to cutting-edge AI and LLM-powered Recsys, you now have the knowledge to stand out in interviews and projects. If this video helped you, hit like, subscribe, and turn on the bell to get notified about upcoming videos on AI ML and generative AI. Drop your toughest recommendation system question in the comments. I'd love to hear from you.